Okay, water flows through orifice inserted in steel pipe. The orifice and the pipe internal diameter are 50 and 102 millimeter, and data given 1000. So sometime I do not give, then water if I say, then it is 1000. Okay. Coefficient of discharge 0.6 is given, pressure difference is given 2. So, okay, so this is 1, this is 2. Okay. So, del P is given 1 and 2, like if I make this U tube. So, pressure difference del P is given here instead of height, directly pressure difference is given. Okay. So, D1 D2 by D1 is equals 0. Or 50 direct I can write 50 by 102. So, it is given 0.49. Okay. CD value is given 0.6. So, CD you can get from the table. If I give table, then okay. If I do not give table, then I will give the value, or you can guess certain value if I ask you, guess yourself. Okay. So, CV 0.6, CD 0.6, rho water is given 1000 kg per meter cube, and del P given 20 kPa. Okay. So, M equals CD, why M directly coming? It should be Q. Q equals CD A2 rho del P by rho, this is 1 minus A2 by A1 square. So, this will be giving 0.6 into pi by 4, 0.5 square, 50 millimeter, orifice diameter 50 millimeter, right. So, if I convert to meter, it will be 0.05, 0.05, yeah, meter square, 4 root over 1000 into 20,000 kPa is there. So, into 2, and root over is there 1 minus 0.49 power 4. Why it is becoming like this, like A2 by A1 equals pi by 4 D2 square by pi by 4 D1 square, right. So, it is becoming like D2 by D1 square, but in actual term it is there A2 by N square is there, okay, by A1 whole square is there, that means D2 by D1 whole 4, okay. So, that term is kept here, delta P by 1000, okay. But why I am writing kg? It should be volume flow rate. So, it is meter cube per second, 7.7. Just check please, this calculation is okay. I think I have done some mistake here. Because I have written M, it should not be M, it will be Q. No, 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 no. I think last result is okay, but Q is wrong. The 7.7 is coming mass flow rate or volume flow rate? No, no. Volume or mass? No, my formula correct or not? 8.55. This is mass flow rate, but Q value not required.
Q is 0.0085
meter cube per second. Okay, so it will be, you are saying like I delete this one, like 0.0085. Like this. This is okay, na? Okay, so when I come mistake, okay. So I'll record this one. Okay, from this calculation we are getting value of flow rate, volume flow rate is 0.0085 meter cube per second, and mass flow rate will be multiplied by rho. So Q rho, it is coming 8.55 kg per second. Fine. Okay, so here another flow meter called Peter tube or Peter tube, many people say. So Peter tube, like, it measures difference between fluid static and dynamic pressure. Okay, so how it is measuring? I have one pipe. If I put very narrow tube, very narrow, let's say 1 millimeter thickness or hole inside, so what happen? All the fluid particle will be passing through this one, but some particle will not pass through this. Okay, it will get stagnated. So if I have one measuring instrument here, we will get stagnation pressure. Okay, and let us say if I have different type of fluid inside, so fluid level will be going up. So that will be showing stagnation pressure. Stagnation pressure is total pressure. That area, because high velocity fluid passing through this one. So initially fluid pipe is having certain pressure. Again, your high velocity fluid, you are stopping. Okay, so all velocity will be converted into pressure. So total pressure actually you are measuring. So that is called stagnation pressure. Okay, so that is another fluid measuring fluid flow measuring instrument. So again Bernoulli's equation will be holding here. Okay, so to calculate this one, they have assumed like this. I have one pipe. Okay, I have two holes. One hole is having just hole and one small narrow tube, capillary tube sort of thing. Okay, so this pipe will be giving certain pressure, that will be called static pressure. Okay, and another, I will put some pipe directing towards flow direction, opposite to flow direction. Okay, so that fluid will get stagnated. Okay, velocity, fluid velocity particle will be stopping for certain moment, and it will be increasing pressure. Okay, so that pressure will be rising this fluid column level. So this difference is H. Okay. Now if I use Bernoulli's equation, it will be like this: P equals half rho v square plus rho gh equals C. Now if same height is there, then rho gh will be 0. So P1 plus half rho v square gamma, gamma means omega, gamma value is actually rho g. Okay, rho, they have used the term. So P2 half rho v2 square v2. Now what is P1, P2? I said this may be P1, this may be P2, this is maybe P1 here, P2 here. Okay. Now V2 is 0. Okay, so V2 is 0 means pressure will be higher there. Now from there we are getting like, if I use this Bernoulli equation, finally it will come like this. So V2 is 0. So you are getting V1 equals to P2 minus P1 divided by rho per half, and P2 minus P1, if I write del P equals P2 minus P1, then it is getting simplified like this. And if there is certain loss in Peter tube, then we have to put on constant also. Okay, so 100% pressure will not be converted, maybe there will be certain losses. So that term, so 0.95, 0.98, so that much of value they will be taking, and based on that they will calculate. Okay, so del H means how much fluid is lifted. One column is here, another column is here, so that difference del H. Okay, so based on that you can do some calculation also to calculate flow rate. Let's see, if your fluid is water and H is 10, so this H is 10. Okay, calculate velocity, fluid velocity, and C value, let's say I am giving 9, just assume, take G value 10 meter. So velocity C equals square T 2 GH. So you can calculate also C square it 2 into 10 into del H, del means 0.01, right. So 9, 0.9, this is 0.9. So you can get directly one value, fine. So this is left for your own calculation. Okay, so U-tube pressure measurement. So vertical U-tube possible. Okay, you sometimes we give very heavier fluid like Hg, sometimes we give lighter fluid like aniline sort of thing, so lighter fluid, okay, and we try to check what is the pressure difference. Like, so I have one pipe and I am putting tube like this. So if there is any obstruction or anything, then it will be showing different pressure. Based on that, we can get flow velocity measurement, flow velocity, flow rate to mass flow rate we can calculate. Okay. So in some cases it can be inclined also based on your application area. Maybe certain pipe they are not allowing to put vertical, so there may be some inclined E tube also. Okay, you say my pipe is like this. Okay, so I will get inclined flow meter. So in that case, let us say my mercury level is going like this. Okay, and what is the angle? Angle can be like this, theta. Okay, and this level can be h. So if I get h, then you have to convert to vertical, because h rho g related to your gravity. Okay, so you have to convert, you have to use sin theta function. Okay, so del p will be gamma or h sin theta. H means the distance, gamma means the g, specific weight we can say. Okay, rho g. Okay, h is that height, and sin theta is this theta angle. So then you can get del p. Okay, you are not getting directly if I give inclined tube formula. Many time I give, instead of saying h, I will say okay, pressure difference or vertical height is this one. Instead of h, h means you have to calculate sin theta. If I say vertical height, that means you should not use your angle. I am giving directly vertical height. Okay, although angle will be there, I will be showing everything, but just to confuse you, I will write vertical height. Mercury is connected to between 2 points. If the manometer reading 26 millimeter, okay, 26 is the difference. Okay, then calculate pressure difference between the points. Okay, so 2 pipe you have. Okay, so you have to calculate pressure difference between 2 points, 1, 2 maybe. Okay, then water is flowing through the pipe or air is flowing through the pipe. So the data is given, you can see this 20 degree centigrade temperature we are assuming, because air you need temperature R value, but water you do not need actually, because it is incompressible. Okay, mercury density given 30.6, density water 1, molecular weight is 28.8, air molecular weight, air temperature also given, so you have to calculate in Kelvin. So P2 minus P1 equals del P equals rho mercury minus rho water GH, because if it is carrying water, then this column will be filled with water also, this portion will be filled with water. Okay, so when you are calculating, so this portion also you have to calculate. So mercury column difference and water column difference also you have to calculate. Okay, so 13,600 minus 1000, mercury rho, G value 9.81 into 0.026. So normally we give G value also, because many times student approximate with 10, G equals 10. So then result will be different. So maximum time we give G value. Okay, so it will be coming 3214.4 Newton per meter square. Okay, for water. For air, rho equals air density 28 point, air molecular weight 28.8 into, I will write the formula first, PV equals nRT, N by V equals P by RT. Okay, from there you are getting rho equals 28.8 into 101 at pressure 325 divided by 8314 into 293 equals 1.2 kg per meter cube. Okay, so you got density. So del P equals rho m minus rho GH equals 13600 minus 1.2. You got density, air density 9.81 into 0.026. Okay, so this will be giving 34692 Newton per meter square. Okay, so mass density actually mass density rho equals molecular weight into molecular density. Okay, so let's see next problem. One more problem. E2 manometer. This is the last, I think. This is the last problem. So then you have class. Okay, then you have class. Then I'll 10-20 minutes I'll take and finish. Attendance I have not given.
Sir, can you show the previous question?
Anything wrong? I will solve another problem. A problem on Venturi meter. A Venturi meter is fitted in a pipe of 30 centimeter diameter inclined tube. So tube is inclined actually. Okay, tube is inclined, and we have one Venturi meter. Venturi meter is actually a narrow section you are creating. Okay. Now it is inclined at 40 degree, so it should be 40 degree here. Okay. To the horizontal, to measure the flow rate, petrol inside there is petrol. Okay. And specific gravity lower than water, so they are assuming 0.8 specific gravity. Okay. The ratio of area of main pipe this one, and throat is 5. Okay, so main pipe area and throat. So area throat by area main pipe is 5, and the throat is 1 meter from the inlet. So it is showing 1 meter. Okay. The difference in manometer head is 40. So let's say liquid is filled like this, only this section. Manometer is like this, and liquid is filled here. I'll draw properly. Okay, so this section is filled with liquid. Okay, and this difference is the two column is 40 millimeter. Assuming the coefficient of discharge 0. CD is given 0.96. Calculate discharge through the venturi. So you have to calculate flow rate and pressure difference del P between the throat and the entry point of the venturi. Okay, entry point means like here we can put one point, and that point we have to calculate. Now first we have to start with the formula. Q equals C in CD A1. I'll write again. Q equals CD A1 A2 A1 square minus A2 square into 2GH. So A1 is pi by 4, 0.3 square equals 0.0707 meter square. Okay, because 30 centimeter already given. Okay, now Q equals, we put the values, A1 A2 equals 0.0707 divided by 5 equals 0.0141 meter square. Now Q equals 0.96, the CD value given, A1 A2 value we have to put, A1 A2 and root over A1 A2, root over 2 into 9.81 into 0.04, sorry, not square root, it will be bracket. 0.04 actually this diameter. Okay, and this is mercury Hg is given. Okay, so it is 13.6 divided by 0.8, this petrol specific gravity minus 1. Okay, so this will be giving 0.04 86 meter cube per second. So, consider point A and B. PA minus PB equals rho g, rho g and let us say x plus 0.04 g rho mercury minus rho petrol. Okay. So, this value will be coming like right from here 800 rho g is given sin theta plus 0.04 g 13600 minus 800. So, it will be giving 10067.32 Newton per meter square or 10.07 kilonewton per meter square. Instead of x, I will write sin theta. Okay. Now, we will talk about strategic oil. Strategic oil is required when there is any global political conflict or any other issue which will be cutting our supply. For example, India importing 75%, about 75% oil from outside country. Now, because of any political disturbance in oil producing countries, so it will be hampering our economy because we will not be able to import, or maybe oil price will be increasing because of global crisis, because of many reasons, can be internal crisis or outside crisis. Because of that, oil price can go up or supply can be cut. So, for that, to reduce disruption, many governments, they have created strategic oil reserve. And how they have created? So, like for example, US, Israel, Japan, Korea, they have already. India also has created certain underwater reserve system. Okay. So, Global Petroleum Reserve or GSPR, crude oil inventories or stockpile to safeguard the economy and help maintain national security during any energy crisis. Okay. So, energy crisis can be in many ways. It is intended to be used to cover short term supply disruption. So, it cannot give for long term. So, maybe 1 day to let us say 3 months, 2 months, 4 months supply, it can be given from the storage. Indian Strategic Petroleum Reserve Limited under Ministry of Petroleum and Natural Gas, they have created few reserves. From there, India government for military operations, for emergency operations, people can get fuel from there. So, 36.92 million barrel of crude oil to provide 9.5 days consumption. So, very small amount of storage is there in, it's already been created by India government. Refineries, they maintain 64.5 days storage. So, total about 74 days storage is there in India. 3 underground locations, Bangalore, Visakhapatnam and Pudur in Karnataka, already under operation, and some other also under construction. So, the crude oil storage constructed underground rock cavern. So, they will be cutting rock and they will be creating rock cavern and they will be storing there. Okay. So, oil from this cavern supplies to refineries through pipelines, etc. So, this is actually crude oil, not petrol or diesel. So, when you get oil from any wellbore or oil field, so you store there, okay, as a crude oil, crude form. Then after that, you send to reservoir, refineries, and you separate diesel, petrol, naphtha, kerosene, whatever you want to separate. Underground rock caverns, safest means of storing hydrocarbon. Estimated cost of project, it was in 2005 for India, or about 3000 crore. So, it is a huge cost also there, but it is also very much inevitable for country's safety and security in terms of military operations or economical issues. So, all government is trying to build their own storage systems for energy security only. So, thank you very much for today's lecture. We will start new topic on the next day. Thank you very much.